So the last problem we have is number 25, which says, from a raft 50 meters offshore, so here's our raft, it's 50 meters offshore, a lifeguard wants to swim to the shore and run to the snack bar 100 meters down the beach. So perpendicular, the raft is perpendicular out to the beach, and where that raft is perpendicular, the snack bar is 100 yards from that position. So from this point, it's 100 yards to the snack bar. So if the lifeguard swims at 1 meter per second and runs at 3 meters per second, we want to express the total swimming and running time t as a function of the distance x shown in the diagram. So we want t as a function of x. Alright, so t is time, and if we look at trying to find s is a distance. So we're looking at time and a distance, but we also know something else. We know the rate at which he swims, his speed. So we have time, distance, and speed. Thinking about how those relate to each other, we know that speed equals some distance over time. You can think about speed as miles per hour or meters per second. We're traveling a distance over a time. So if we're looking for time, that means we're going to have t equals d over s. You can multiply the t to the other side and then divide by s. So in each of these cases, we're looking for what is the distance over our speed. The distance from the raft to the shore divided by how fast he can swim, and then also the distance he has left to go on shore to the snack bar by how fast he can run. So just to illustrate this, we're looking, the swimming's right there in blue, the running's right here in orange. So I'm looking for t to be equal to the distance he runs, or excuse me, the distance he has to swim. Oh, I wanted blue right there. The distance he has to swim over his swimming speed plus the distance he has to run over his running speed. Oops. That's an S if you can't see that. So his distance swimming over his speed swimming plus his distance he has to run over how fast he can run. So let's fill a few of these things in. So we know that he can swim at 1 meter per second and he can run at 3 meters per second. But we need to know the distance he has to run and the distance he has to swim. To find out the distance he has to swim, we can just go over here and look at this triangle. So we have a side length, or two side lengths, and we just need to find that s. The side length is x, and we want it in terms of x, so that's why I say we have two side lengths. When we do that, we can use the Pythagorean theorem, a squared plus b squared equals c squared. A is 50, b is x, so 50 squared plus x squared is equaling the hypotenuse squared, which is s. 50 squared is 2,500, x squared, to get s by itself, square root both sides, so s is equal to square root of 2,500 plus x squared. So that's the distance he has to swim. So I'm going to put that right here, 2,500 plus x squared. Sorry if that's a little bit small. Alright, now I need to find the distance he has to run yet. So I'm looking for the r distance. Well, this total beach line that he has to travel, either by swimming or running, is 100 meters. But he already swam x of that. So what he has left is 100 minus x. That's the only distance he has to go. So 100 minus x all over 3. Alright, so did we answer the question? Did we put time with respect to x? Yes, we did. So if you want to, you can rearrange this, find a common denominator if you wanted to, but this is all we really need right there. Then it asks us to find, using a graphing or computer or graphing calculator, to find the minimum time he could take to get to shore, or to the snack bar, excuse me. You would just go ahead and put into your calculator that equation. It's going to look something like this, where we have x as the x-axis and t as the y, and it's asking for the minimum time. So at that lowest point, what would the time be? So that's the y coordinate. So what is the y coordinate at this point? And t is about 80.5 at this time. So that would take a total of 80.5 seconds about for him to swim from the raft to the shore and then get to the snack bar. So that's the fastest he could do it with what we were given. And that answers all the questions.